In this tutorial, we will see how to compute the process capability ratio and the process capability index. The slide shows some nuts and bolts from a local home improvement store. If you grab a bolt like this and a handful of nuts for that bolt from your home improvement store, you will quickly understand tolerances. Some of the nuts will easily screw onto the bolt. Others will be so hard to turn that you will need a wrench. Others will be in between. Yet, they were all acceptable to your local home improvement store. Stated another way, your local home improvement store is tolerant of small deviations in the size of the bolts and nuts that they purchase. All they care about is that they be close enough that you can screw the nut onto the bolt. On the other hand, if a car manufacturer were buying the same size bolt, they might be less tolerant of size deviations. A company making nuclear reactors might be less tolerant still. Tolerances are the range of acceptable values for an item established by the customer. For our bolts, they will be the range of sizes the customer is willing to accept. So, for example, if the bolt is supposed to be 0.25 inch in diameter, a particular customer might be willing to accept anything from 0.24 to 0.26. Tolerances are also known as specifications. Process variation is the variation that is natural or inherent in a particular process. In other words, it is the variation that will always be a part of the process. All processes have variation, and the amount of variation varies from manufacturer to manufacturer. All customers establish tolerances for the components they purchase. As we have seen, different customers might have different tolerances for the same component. Process capability measures how well a manufacturer's process variation matches the customer's tolerances. This is not a value judgment. Not being able to meet their needs does not necessarily mean a manufacturer needs to improve their process. It just means this particular customer is not a good fit for their manufacturing process. After all, a company making bolts for your local home improvement store most likely does not also make bolts for nuclear reactors. We will look at two different but related measures of process capability, the process capability ratio, or C sub P, and the process capability index, or C sub Pk. We use the ratio when the process is centered. That is, we are sure that the average size of the bolts we are producing exactly matches the size the customer wants. We use the process capability index when we are not sure the process is centered. That is, we are not sure the average size of the bolts exactly matches the size the customer wants. The process capability ratio is just the ratio of the specification width from the customer divided by the process width from the manufacturer. This equates to the upper specification minus the lower specification, all divided by 6 times the process standard deviation. The process capability ratio is the smaller of either the upper specification minus the process mean, all divided by 3 times the process standard deviation, and the process mean minus the lower specification, all divided by 3 times the process standard deviation. A manufacturing company has a customer who wishes to purchase bolts that are 0.25 inch in diameter plus or minus 0.01 inch. That is, their tolerances are bolts between 0.24 and 0.26 inch. The company has 3 different processes that can produce these bolts. Their means and standard deviations are shown on the slide. Determine which processes are capable of producing these bolts. For process A, the upper specification, or tolerance, of 0.26 minus the lower specification of 0.24, quantity divided by 6 times the standard deviation of 0.004 equals 0.83. This indicates that the process is not capable of meeting the customer's specifications. In general, a value of 1.00 indicates barely capable, and values below 1.00 indicate the process is not capable. A value of 1.33 or higher indicates fully capable. When the process capability ratio shows a process to be incapable, there is really no point in computing the process capability ratio, but we will do so anyway. The upper specification of 0.26 minus the process mean of 0.25, quantity divided by 3 times the standard deviation yields 0.83. The process mean of 0.25 minus the lower specification of 0.24, all divided by 3 times the standard deviation yields 0.83. The minimum is 0.83, so the process capability ratio is 0.83. 2 notes are in order. First, when the process is centered and the customer specifications are symmetrical about the mean, both of the values you compute for C sub Pk will equal the value computed for C sub P. Second, one mistake I see a lot of students making in calculating C sub Pk is calculating the 2 values but not take the last step of picking the minimum. For process B, the upper specification of 0.26 minus the lower specification of 0.24, quantity divided by 6 times the standard deviation of 0.002 yields a CP value of 1.67. This was seen to indicate that the process is very capable. However, in calculating C sub pk, we see differently. The upper specification of 0.26 minus the process mean of 0.245, quantity divided by 3 times the standard deviation of 0.002 yields 2.50. The process mean of 0.245 minus the lower specification of 0.24, quantity divided by 3 times the standard deviation of 0.002 yields 0.83. The minimum is 0.83, so C sub pk indicates the process is not capable. Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. For process C, the upper specification of 0.26 minus the lower specification of 0.24, quantity divided by 6 times the standard deviation of 0.0024, yields a C sub p value of 1.39. For C sub pk, the upper specification of 0.26 minus the process mean of 0.25, quantity divided by 3 times the standard deviation of 0.0024 yields 1.39. The process mean of 0.25 minus the lower specification of 0.24, quantity divided by 3 times the standard deviation of 0.0024 yields 1.39. The minimum is 1.39, so C sub pk indicates the process is fully capable. If you found that this video helped you with your operations management problem, please consider liking the video and even subscribing to the channel.